Good evening, everyone, and thank you very much for joining. Very nice to see so many of you on tonight. Just some quick notices. Obviously, tomorrow it's the funeral of Bill G4WJS. Details are all on the Google group that have been sent round, but it's at 1 o'clock tomorrow at Amersham Crematorium. And there is also an online thing, streaming that you can use. That is also included on the email that I sent out. So hopefully you've all got those details. As regards the situation with meetings, etc., we're hoping that in February we can sort of resume a little more normality. I'll be asking the rugby club if we could do our usual sort of informal meet on the first Thursday of the month, and then subject to everyone being happy with it at the time, we're hoping to bring back the hybrid meetings for the February meet, but that's not definite yet. We'll confirm that via email a little bit nearer the time, because as you appreciate, things are still a bit dynamic, really. So with that, any notices from the committee?
Everybody that's paid their subs so far should have got an acknowledgement from me, a confirmation email over the weekend. For those that haven't paid, I'll send out a reminder soon, so that you've got the payment instructions. So lots of people have paid up already, which is great to see. There are a couple of people who've joined who I have absolutely no idea who they are, but I'll chase that up with the committee at the next opportunity.
Okay, thank you, Barry, and thank you very much for everyone who has taken the trouble to do their subs and everything. That's much appreciated. Thank you very much. Any more notices from the committee? Yep,
next meeting is 2 weeks' time, and it's by Marcus Curler, and he works at the this is a tricky one to say, the European Centre for Medium Range Weather Forecasting, ECMWF. So he's an atmospheric scientist by trade, and he'll be looking at aspects of environmental protection and all matters related to what we're doing to the planet, and also well, particularly with regard to space or high altitude travel, shall we say. He's quite concerned about that, and the likes of Jeff Bezos nipping up there for a little jaunt. So he's still working on the talk, and he may try and cover a few radio bits as well, but he's not a radio. He's not versed in radio by trade. So yeah, and hopefully we'll learn a bit about ECMWF.
What might be relevant there, John, is you know, for VHF propagation, things like temperature inversions, which cause enhanced conditions. So if he covers any of that, that would be very relevant.
I could certainly mention it to him. Yeah. So yeah, so hopefully we'll learn a bit about the establishment he works for as well. That's it from me. Thank you.
Okay, thank you very much, John. Any announcements from the members? No. Okay, so
very quiet.
Yeah. So
there's one advantage to a Bluetooth mic. It's the lead on a traditional headset is unfortunately a cat toy.
Oh yes, so that could be fun. Yeah, watch your facial expressions through
God. I'll shut up now.
Okay, so it's a great pleasure. Now I hope I pronounced this correctly, but great pleasure to welcome to the club tonight, Dr. Bob Heil, K9EID, who's very kindly offered to join us remotely to give us a talk, which is entitled The Science of Audio. And he's already been very enthusiastically talking to us. So a very warm welcome with many thanks, Bob. And I'd like to hand over to you. So welcome.
All right. Well, thank you for having me. I love coming to club meetings, especially in the UK. I've done about 10 of them over the past couple of years, and I'm so glad to be here. Now, one thing you might want to do is do a speaker view, because I do all the slides from here. I don't share my screen. So I do all the switching from here, and we'll need to, if you want to have a full screen, there you go. We're all ready to go. Okay, well, let's get into this. There's so much to talk about. Sometimes these things could last 3 hours, but this one won't. But one of the things I like to do is to talk a little bit about the microphone and the antenna. There's a lot of things in between it. We'll get into that in just a little bit. I want to take about 5 or 10 minutes to tell you about where I came from. Actually, I started when I was 15 years old playing the cinema organ at the Fox Theater here in St. Louis. Now, why I take time to tell you this, that organ hadn't been played in 20 years. And the regular organist there had hired me to be a substitute, but also we had to voice and tune about 3,500 pipes from 1 inch to 32 foot. That's where I learned to listen. Listening is a mental process. You go in and dissect the harmonics and the distortions and whatever. And I really learned to listen. And little did I know that it was going to be the basis of 2 of my careers later. Got into ham radio in that same year. It was all on 6 meters. I loved the VHF because in those days, 1956, the bands were open all the time. When I say that, people say, yeah, right. No, it was amazing. It was the start of the largest sunspot cycle. And boy, did we have fun. Had a Harvey Wells TBS 50, SX99, and that's an RME VHF converter. And I was a 6 meter nut for many, many years. And also 2 meters came along. Over there on the left, you see a little box, a little blue box with a meter. I wish I had the whole picture. I wish I had it. I hadn't been on the air about a month, and I read this article in QSD as to how to build a 6 meter transmitter with a 2E26 and a 5763, so on and so on. And it was wonderful to be able to build. Building became almost, it was a disease for me. And my life went on. I got into building PA systems, and we're not talking little bitty ones, we're talking about great big ones for all kinds of groups. And we really started out with the Grateful Dead. I was with them and helped them through a couple of their tours. But then we got involved in Jimi Hendrix, did some of his stuff, but then they were all calling me because we were the only ones that had a large PA at the time. And I was so fortunate that I had the knowledge to put all this together. Many of the English bands, Jeff Beck and the Who, and all of these guys came over and we were doing their tours, and it was a lot of fun. But one of my great friends out of that is Pete Townsend. Pete and I still communicate, have lots of good times. But we had 35 people working in our plant building amplifiers, and that's a talk box. Of course, we were very famous for building the talk box for Joe Walsh and Peter Frampton. That's a whole nother story. But I got into doing some festivals, and they were really treacherous to work, because this particular one, they said, well, we're only going to have about 20,000 people. They had 100,000 people. It was ridiculous. I said, goodbye. I saw too much of that, but working with all these great bands, and still with many of them and doing their microphones today, I wrote the book. As everybody had asked me, I'd go in, how'd you learn this? What did you learn? How'd you do all this? How do you hook up all this da-da-da? Ham radio is where I learned it. I didn't go to college. I hardly made it out of the 8th grade. I did go to high school, though. But the deal there is that I thought it was time. So I wrote the book, and it became the Bible for live sound engineers in the 70s. And met up with Joe Walsh, WB6ACU. We're still great friends. And that was with the James gang. But it ended up with all that with the talk box. I built the talk box for him. And I'm sure that all of you know about the talk box. It was very substantial in his career. And Peter Frampton came over with Humble Pie. And we did just about all their shows in America, and a few over there also. But his little girlfriend, you see there, Penny McCall, she called me one day, wanted a Christmas present for Peter, said, do not send him a guitar. So what did I do? You know what I did. I sent her a talk box. We're still great friends, and things are just having a lot of fun doing their microphones. But my life changed really quickly. I got a call in the middle of all that from Paul Klipsch. This is where you want to start taking notes, I'm sure. Paul was the guy that brought hi-fi to the world. He started the Audio Engineering Society. And he called me. I couldn't believe it when he called. I'm like, gosh, this is Paul Klipsch. This is like audio God on the other side of this phone. He wanted to come and see that 8,000 watt PA that I had. He didn't know you could waste that much power. So he flew his airplane up to my hometown. It was Marissa, Illinois, about 50 miles southeast of St. Louis, down in the coal fields of southern Illinois. And all day long, he was much taller than I, looking, well, why'd you do that? Where'd you do this? How'd you learn to do that? Ham radio. No, like, where did you go to school? I didn't. I learned how to build from ham radio. And that's the theme throughout this whole thing today. Amateur radio has built my life and built my careers. So he put me in his plane, took me down to his home of Hope, Arkansas that night, spent the next couple of days, and it was incredible. I learned so much. I was writing things down as he would give them to me. I didn't learn them all that second, but I could go to the library and get what I needed. But Paul, he came up with the folded horn. He was the first guy that built a horn, folded horn for a residence. And what you see there, when I bring it up, that's his K horn. He made it out of plexiglass just to show it there in his showroom. It fits in the corner of your room, and you have to have an 8-foot wall and an 8-foot wall coming together in the corner. And those two 8-foot walls, they're the extension of the last 16 foot. And so when you listen to this thing, you don't listen to it, you experience it, because your room is part of the speaker. It is absolutely stunning if you ever experience a K horn. Well, he got to telling me all about things, and he said, now, young man, I want to get you into something that I think you might need the reference. And What he was talking about was the telephone system here in America. The telephone system, when they first hooked it up, it didn't work well. It was mushy, bassy, no articulation. And they had taken 2 wires from New Jersey all across America to California. Every 500 miles was a relay station to keep the level up, keep the frequency up, so that when they got out to California, everything was great, right? Well, not so quick. Because when they did that, this is what they heard. This is the response they heard. And it certainly wasn't articulate, and it certainly wasn't something of great communications. What were they going to do? They didn't understand what the problem was. Everything was equal. Let me get this back up. And so they needed to find out how they were going to fix things. They turned the scientist onto this project. 4,000 scientists at the Bell Labs. And they were just, all of them very, very stunned, because this thing should have looked like that, but it didn't. It went in, but it didn't come out when you're listening through a telephone, the human ear. Well, the 2 lead scientists were Dr. Harvey Fletcher and Dr. Weldon Munson. These guys figured it out with the help of their 4,000 compatriots. What they discovered is that we don't hear the same in different levels and different rooms and situations. They came up with their Fletcher-Munson curve. I would hope that many of you know about this. You notice up at the top, if you're at 100 to 110 dB, the audio is almost flat, what we hear. This is a curve of the human ear. You get down here about 20, 30 dB of level in the room, it looks like a ride at Disneyland. Well, what they came up with was this. And if you don't take anything away from today, this is what I hope that you do take away. They discovered that, first of all, the bandwidth is 300 to 3,000 cycles. Kind of sounds like something you talk into every day, isn't it? That's about what our amateur radio transmitters are. Well, what they discovered is the human hearing system needed to have that rise at 2.5K. You want to remember that, because it is very important. I'll do this one more time. I have a parametric equalizer in this mixer. And all I'm going to do, I'm not touching the bass, nothing but the mid-range. I'm going to take it down. There it is, it's gone. And so now what do you have? It's very mushy, mundane, and really difficult to copy in some kind of a pileup because of that articulation factor. Going to turn that back on. Only 2.5. I'm not touching anything else. 2.5. And you can hear when the sweet spot hits, there's about 1,000. Here comes 1,500. But the minute I get to 2.5K, it's like, wow, somebody just turned on a light. The F and the S, the P and the B, there's an essence of sound. That essence of sound is not there. The F and the S all sound alike without the 2.5. Bring it back up again. And so we have to learn from these fellows. Wow, I guess we need to really focus on that 2.5. Absolutely. But go back to the scientist again. what are they going to do? They've discovered the problem, but how to fix it? There were no equalizers, there wasn't any of that stuff. But they did have low and high pass filters. So they took a high pass filter with a certain value of capacitor, certain value of resistor. The capacitor will pass all of the highs, the whole program actually, but that resistor to ground will reduce some of the low end. And so that's what they had to work with, and it worked. And so now the telephone system was very respectable. Along in that time, the end of the 20s, this man, look how young he was, John Volkman. He was working at RCA, and they had him work with motion picture systems. The motion pictures were coming in the 1930s, and they took him off their regular job, and he was to go in and fix all of the motion picture playback systems. And how he did it was using high pass and low pass filters. He built this little test gear, inserted it from the program source into the audio amp, and what happened there is he could select different filters. He didn't have to do a bunch of soldering and all that. He just had some samples. And once he figured one of those out, then they would hardwire that. Well, you know, one of the most interesting things that Paul Klipsch turned me on to was all of the things that we need to know about audio. And most of it's right here. The Audio Cyclopedia. If you've never heard of this, this is an amazing book. It's 1,800 pages. And that's what I really had to go by when I started thinking, wait a minute, I'm not doing this right. And it was my Bible. It was my teacher. And all of this stuff is well defined in there. But here's the story. Now check this out. From 1930 to 1967, there were no equalizations. There wasn't any. It wasn't talked about. In the 50s, when high fidelity came in, there was a little rise with it, but it was just a passive filters with variable resistors. It wasn't great. It didn't work really good, but it worked. So what are you going to do? How's it all going to happen? And so in 1967, I think again, there was nothing talked about equalization all through those years. In 1967, Langevin came up with the very first professional equalizer. You could select a frequency at the top and you could boost or cut it. It was a huge step forward. Well, I learned about this, and I was in the sound reinforcement business, so I better go check it out. So I go out to California and visited their plant. They built a recording stuff for recording studios. And so while I was there, something else hit me, because in the early days, when, as I told you, when we got into the sound reinforcement business, we didn't have any mixers of any really good quality. All they were mixers that we'd used in broadcast stations. And just there's 4 or 5 examples of that. It was like that bottom one, that green one you see, that's what I used for most all of it. There's no equalization. It was just 6 channels. And mixed Jimi Hendrix and all kinds of people until 1968. The reason happened there. I go out to Langevin to look at the equalizer, And boy, do we need it. When you see all this stuff, you're going, boy, you really do need equalization. And so what I did, jumped on a plane, went from St. Louis out to California, and they showed me their equalizer. Yeah, this is great. They said, yeah, well, let's show you something else. They were building the first mixer. It was really incredible. It had slide controls, and you can't mix with rotary controls, so you can't see where they are. With sliders, you know right where they are. So I bought a pair of those, came back to my hometown, and I had a carpenter build me a really nice cabinet to put it all in, something we could travel with. It had big, sturdy steel legs, but I bought two of those. The 2 meters on the panel above, that was their compressor limiter. That was extremely helpful. And of course, that came from the recording studio. But up there where you see a light, it looks like the flash had shined on it, I guess. Look what was there in 1968. Oh my goodness, I couldn't believe it. Langevin and Altec had gotten together and they brought out the very first graphic equalizer. Well, you can be sure that I jumped on that quickly. So then when we'd go on tour, everybody would freak out, and it really moved Heil Sound up the totem pole pretty fast because we had this fabulous mixer with the equalization, compression, limiting, and all of that. It was really something. But I had been on the road for about 14 years. I kind of got tired of it. So I thought, you know what? I think I'm gonna get back to radio. So I get back to radio. But wait a minute. What happened to my great Art Collins audio? I mean, my station grew quickly. We were doing all kinds of things. One of the things I was doing, I was the father of FM radio for hams. I built the first FM transceiver, and it was a converted CB radio. And we sold kits for several years. The Sunspot cycle had come back up again. You could take a little 5-watt CB radio, change the crystal, drop in the parts, FM demodulator and stuff that we had built, and you'd be on 10-meter FM. Had a repeater offset so you could work repeaters. It was amazing. In fact, I wrote the book, the 10-meter FM handbook. ICOM came to me and said, well, what's all this about this FM stuff? It's a mode that we need to look at, and it became very popular in those days. Around the turn of 1978 through about 84 or 5, and ICOM started asking questions, and they work with me, and so their 735 was the first transceiver from the manufacturers that had 10-meter FM in it. And I helped them get all that going. But back to the radio, what happened to my great Art Collins audio? It's like, I couldn't believe it. It was terrible. And again, it was all mushy and bassy, just like we heard with the telephone system. It's like, there is no articulation when you try to give your call and tell people signal strength and so on. It was hard to understand, and basically a lot of it was very distorted because it didn't have any equalization. That wasn't around. So I thought, aha, I'm gonna have to borrow a few thoughts from John Volkman. You remember him? Took EQ to a new height back there. And I built the very first equalizer for ham radio, the EQ200. I built it for myself. I didn't know where this is going. No one ever knows the future. You just have to live it as it comes. And I built this little box with a 2-band EQ in it. I thought, well, that'll be cool. That'll be cool. And I did this again. I was on. I went when I got my license back in '76. I got an extra class, so I was working the low frequencies. But I built this little box. We were on 40 meters every night with it. It was really great. A lot of people, wow, what is that? And so I wrote an article for QST. And in July 1982, it was published. And I wrote the article as a do-it-yourself, a DIY. But it backfired on me. I put my phone number in there and people started calling me. They didn't want to build it. They wanted it now. Oh boy. So the plant had been closed, building all the sound stuff for years. So I opened it back up a little of it and got 2 of my solder gals, and we were off and running building EQ200s. It was the first product of Heil Sound. The other Heil Sound was closed back in around '79. That was strictly for the rock and roll and all the other things we did. But it was a very interesting little box. Put your microphone in, take it out of here, and go to your transmitter. Ran from a battery, or you could power it also. And the filters were easy to come by after I played with it on the air a lot. But reading Paul Klipschen, all of the notes we had to have 2.5K. You know that. I proved that to you. So the top filter sits at 2.5. You can plus or minus that. You always want to plus it. You would never want to take out 2 point, but if you did, there it was. What was the bass? The low frequency was set at 160 hertz. We could notch out some of that bass. We could increase it if you want, but you never want to do that. You heard what happens when you turn up the low frequencies. So this was quite a deal. It became very, very popular in the States and some in your country. We were shipping parts to. Well, I got a letter in about 99, at the turn of the century. It was from Dr. Inouye of ICOM. He had a picture of his station. It was their great IC 781. Remember that? The one that was the first one that had a scope in it. It was actually a CRT scope. It was the DX Dream Machine. It was really great. He had a picture of that station, and that picture showed he had one of my equalizers, of course, the 781, and he had one of my Gold Line microphones. This is the guy that started and owns ICOM. I'm thinking of new radio line, and I want to use EQ200 circuitry. And so they did. From the Pro 1, Pro 2, Pro 3, all the way through the ICOM line. What you see behind me, the 7300. The latest one, the little wonderful, I love it, 705. Wow. All of these things had my 2-band equalizer in it. They sent me the 705 because just in process of building the adapter. It was a real funky thing. I don't know why they did that, but it's got a funky circuit in the mic circuit. And so they weren't going to do anything about it. They didn't. So now we have the adapters so we can plug headphones and microphones, but they have to be our IC microphone, you know, for a standard ICOM. But that really started the equalization craze. But the problem was a lot of guys didn't understand it and they didn't want to use it. So they just stayed in the default mode. It makes me very sad when I get on the air these days. And every once in a while, because I always ask them, I can usually tell if they have their equalizer on and they don't understand it. Well, we started a very cool section on our website, heilsound.com. We'll come back to that later. It's very simple. The first thing you do, what is the first thing you do when you sit down to your radio? I know you turned it on. What's the first thing you do? You don't go dialing around. You set the transmitter bandwidth. And that bandwidth, if you're just doing ragchew, because, you know, once in a while we want to do ragchew. Yeah, we're just going to do that. You set that at 100 on the low end and 2900 on the top end. I don't care what kind of radio it is. You now, and radios today, you can set that bandwidth. So away we go. Then you go up to the transmitter base and roll that off, -2 or 3, plus the treble. That's 2.5K you're bringing up. You can't change the 2.5K, but you really don't need to. We did that for you. If you're going to do DX work, what's the first thing you do? 500 to 2500. We want to notch out all of those low ends that don't mean anything. The low end just mushies things up. And so for contesting, we don't care how terrible we sound. We want everything to be articulate. I have a great demonstration. Watch this. If the air in this balloon was RF, the first thing you do, as we said, set the bandwidth, going to narrow it, but you open at 2.5 wide open. And when you narrow it up, the RF only has one place to go. Where's it going to go? It's going to come out at 2.5. So you're going to have rich RF at 2.5. You've heard several times how important 2.5K is for the DX and contester and for just nets and stuff like that. You really want to get through pileups. That's how you do it. You narrow it up and open that 2.5 and away you go. That was very simple, wasn't it? And so I really am happy to help all the people that are trying to make things happen. There it is right there. There's no secret. It's just fact. And all the ICOMs have different window looks, but it's all the same thing. You'll see there -2 on the bass, +3 on the treble, and so on and so on. There's the microphone that we build for them. It's really wonderful. It doesn't work on Kenwood. It doesn't work on anything except an ICOM. And the ICM, it almost spells ICOM. And it really, really works great. But a year or so later, at Dayton, Dr. Hasegawa came to me, and he's a big, tall guy. He says, I want to do it better. I said, oh, what are we talking about here? At EQ stuff. Oh, okay. Well, the only way to do it better would be to do a parametric. That'd be good. Not so fast. What'd be the problem? Education. You see, with the two-band shelving, I figured out where the filters should be. And you're not going to be able to change them. We don't want you to change those. All you're going to be able to change is how much of each filter. So everything works great there. But when you get into parametrics, we're going to do 3 filters. There are 9 controls, not 1 or 2, 9. And you have to know where every one of them is. Here, I've already set it for you. All you have to do is turn it on or off. Here, you got to figure out what each frequency is doing, what plus or minus and so on. And so most people with Yaesu do that. Heck with it. Oh, let's go into default mode. And so when they do that, this is what an icon or a Yaesu or ICOM can with any of them sound like without in the default mode. No EQ, that's just the way it is. That's stupid. No, come on. You got that great tool. So all we got to do is learn how to adjust it. Isn't that a great difference? It's amazing, isn't it? And so what you have to look at, basically in the Yaesu, they have 3 filters. We designed 3 filters. Each one of them is frequency, level, width. We'll go over on the right side of the columns. Frequency, level, width. And you do that. Frequency, level, width, frequency, level, width, frequency, level, width. And so here we go. The first one is going to be 200. It could be 160 hertz, whatever, somewhere in that bass end. Then we're going to minus it 3 or 4 dB. We're going to cut that. And the bandwidth is 2. That's 2 octaves of bandwidth, audio bandwidth. Then what do you do with the second one? Where do you put it? See, this is the problem. Well, there's something that happens between about 500 and 1,000 hertz. It's real boxy sounding. And if you do this to your ears while you talk, you can hear that boxy sound. And we want to get rid of that. And so set the frequency at, usually 800, 900, somewhere in there, minus 3 or 4, and 2 octaves of bandwidth. You know where you're going to put the third one. I don't have to ask you. It's going to be 2.5K, and it's going to be plus 6 or 8 dB, 2 octaves of bandwidth. Now, all that stuff I fuzzed out on the left, every Yaesu have different assignment numbers. 201, 202, 203. Another one will have 301, 302. Another one 401, 5. We don't care. That's why I blurred it out. There are just 9 filters. Go in, set it up, 200, 900, 2.5. Just do it. Don't ask questions. Just do it. And all of a sudden, bingo. But there's one thing you got to learn about Yaesu. The program button. When you push that on to turn the equalizer on, when you finish all these, you have to hold that in for about 3 or 4 seconds. It saves it. It is a computer. Just like any computer, you have to save things. And so you want to save it or none of this works. So be sure you do that. All of this is on my website. Real easy. There's all the setups that we just went through. Now you'll notice the bottom half of that's in red. If you use the compressor, you have to re-equalize the compressor. Personally, and I prove it almost day in, day out, we don't need compression. No, we need equalization. Compression just adds distortion and all kinds of problems. I hear guys with compression and guys want to argue with me once in a while, and then I get into the equalization thing and prove to them, no. The important thing is equalization and bandwidth. But all of that's on my site, and you can go check that out. We also built a microphone for the Yaesu, the PR781. It is absolutely a miracle microphone. It really works great. It's become the podcaster's dream microphone. It's a dynamic, large dynamic, and it works really well. So those are some of the things that we have to think about. But what if you got vintage gear and you don't have equalization in it? Well, that's easy. I have lots of vintage gear over here. That's all my vintage stuff I've had for years. That central electronics that you see right there, built that from a kit in 1958. And so many of those things have been with me all through the decades. I'm on the air every morning on 3885 with usually the Harvey Wells down, you see that way down in the bottom there, down in the lower bottom. That Harvey Wells, I was on this morning with it, original power supply. Thing still has original tubes and capacitors. I can't believe it still lasted, but I'm not one to really push things real hard. The central electronics amplifier, the last one on the bottom, the 600L, 1956. Check this out, guys and gals. 1956, 813, 600 watts, no tune. There is no bass load or plate control, nothing. All there is a band switch and a meter switch. It is truly a no tune linear because of broadband coils that Wes Shum and Joe Batchelor did back in I think they did those in 55. But I love all this old stuff. So if you have any vintage gear, no problem. You simply go in and look at either Julius Jones or Sergi UR6QW. He's got a nice little equalizer. So you have to think about those kind of things. Set the bandwidth. Don't forget that bandwidth. Because the problem you have there is you look at the 2.4. You go out and you buy one of our PR781s or our PR40s. It gets up a little wider than that. You're going to call me and say, what's wrong with this microphone? There's nothing wrong with the microphone. Your transmitter is restricting any kind of nice low end and really nice top end. Only the mid range is there from the filters in your radio. So you have to be sure you understand that. Back in 1984, I came up with what we call the contest dream machine. I can't tell you how many tens of thousands of contest operators have this as their microphone. It's very articulate. It rolls off everything. Look at that. Everything under 500 is gone. And it has a 10 dB spike. It's terrible sounding. Why would you want to do something terrible? Because it puts everything you can garner into that little narrow path. Remember, we talked a lot about it right here. Because 2.5K is the important thing. So when the contesters give out their call, you hear it. One thing that all stations should have is a scope. I was at a ham fest. We had an open ham fest, one in years, finally opened this past weekend here in St. Louis area. And I was seeing scopes for like $50, $70, $80. These are thousands of dollars new, but now they want all digital stuff. We don't care for that. We want analog stuff for this. Buy it. What do you do with it, Heil? I mean, come on. What do you do with it? So I got one. Oh, that's simple. You go build him a little box, find a parts company. Antique Electric Supply in Mesa, Arizona is amazing. Look at their website. Antique Electric Supply. Whoa, you can get all kinds of antique things. Get that little box. I took a piece of RG8 coax, the center of it with the milky stuff. Just a straight piece of wire will do it too. We're going to just couple those two connectors together. It just passes through. Hello, goodbye. And then you add a voltage divider. It's really simple, as you can see there. It's 51K, 680. At the center, the 0.04 that hooks to the RCA jack for the output. That's it. And what that does, that gets you the signal into the scope. The other thing you have to sometimes worry about is even how to use a microphone. Well, I've been talking for years, Heil. What do you mean I can't use it? Well, let me let you in on a few things. You remember this? You'll learn almost everything we're talking about in there, but here's the deal. Every time that you double the distance from the source, you lose 6 decibel. 6. Doubling your power is only 3, and you're going to toss 6 away every time you move away. So you get a desk stand and you're out here. Well, just turn up the gain. I don't know. That just sounds like you're in a roller rink. No, it's very echoey. No, you can never be more than just 2 inches. I got back my dynamic range. Hear it? There we go. I lost it all. Transient response, it's all gone. Up here, great. But once in a while, some of us have more air exit than others, call it plosives. And talking into a microphone, the P's and the B's, they'll get to you. That's what these are for, but not so fast. You can't just buy some little dollar thing. You can't wrap your sock around it. This is specially made to not affect these frequency response. And when you put it on, it did not change any of the audio, but it got rid of the plosives. And it comes with all of our microphones. Because it's vital that we have all of these things. But the distance of the microphone is so very important. But all of this stuff is in our website. There are 2. There's a pro side, and then there's a ham radio side. You go to the support pages, and you'll see all of this stuff. There's about 50 pages that help you a lot. And in designing our microphones, we got into a really neat thing. Joe Walsh and I have been really good friends since 1968. He said, you need to build me a better microphone. I said, what are we talking about here? Well, he said, I don't want a microphone that I have to be nailed to all the time. You know, you've seen them. Here, let me change this. They gotta be right here, because if they move off, it's gone. Hello, come back here. I gotta be right here all the time. So don't try doing funny business. Also, if you paid attention, you lost your articulation. I didn't change the EQ. All I changed was the microphone. We built a very nice little rise in this microphone. Now, listen when I change back. I did not change anything but microphones. Notice the presence is so there. Paul Rogers of Bad Company was the reason for this. He asked me to build a microphone that they didn't have to equalize, because he said, I get these audio guys and they don't know anything. So I did. I built a microphone. I call it the PR22, but all of our microphones now have a rise at 2.5K, and you know why. So we're very happy about that. Oh, I didn't show you the best part. I answered Joe. You see, what I discovered is there is a thing that we call power focus, but you never read about it. I learned about it from my big book down there. The power focus is just like an antenna. It has a directional pattern. And it can't be omni all over. We don't want that because that picks everything behind. Just on the front. That was tough to do, but I did it. And so now we have a really cool microphone that we can move 180 degrees around. And if you're not watching the screen, you'd never know I was violently moving this. Well, that is one of the reasons, was because of our power focus. We're the only microphone company doing this. Where is everyone? I don't get it. But I listen to the entertainers, the guys and gals that use our stuff. I listen to them and they tell me what they want. Just like the contesters and the DX crowd. Back in 1984, they asked me to build them a proper headset. And all through the years, we've been the leading company building headsets and microphones for the ham radio industry. That gold one, that gold wireless, you see, that's Carrie Underwood's microphone. But we're just so blessed that so many of the artists are using our microphone, and the broadcasters, oh my. Sirius Radio just tossed all their RE20s, bought 250 of our PR40s that's being used in recording studios. We're just so thrilled that we can answer the problems for many. Yeah, we even answer the problems for Mickey Mouse. But there again, these are all things that we listen to you and we do. Let me turn this on. See, I think I hope get it around here. I think I got this going. You know what? I didn't. Oh, I'm sorry. Yeah, I'm sorry. I didn't hook this up before. But anyway, this has become the headset for all of those doing any kind of contest work or just regular, because it really cuts through. And I've answered all of your quests. You wanted a headphone that had a balance control between left and right, because some guys and gals have more hearing on one side or the other. Not with this, balance it up. The microphone boom goes both ways. Interchangeable elements. We have an element for the ICOM. You take out those two little screws you see and plug in the ICOM element, or a DX element, or a RAG2 element. It's all there. But then the good stuff, if that's not good enough, came about. We're the only headset company in the world for the past 15 years. We have phase reversal. What are you doing? What is that about? If you're listening to a pileup and you hear this little weaky guy way back here, you reverse that phase, he comes up front. You can move signals around in your head acoustically with this headset, with that switch. You read the reviews, you talk to somebody that has them, they just go crazy over it because it really helps you in pileups. I also put another jack, so if you have a monitor or a logger or just somebody listening like on a field outing or whatever, plug your other headset into here. You don't need a bunch of Y cords and stuff. And with all of our headsets, every once in a while I'll read a review. Oh, those darn Heil headsets, they hurt my ears. You didn't read your instructions, because every one of our headsets has a steel band in it. And if that, I got it set for my pinhead now, but don't be afraid. You're not going to break it. You want a big old wide, there you go. Headsets don't do that. Most of them are made out of plastic. They like to call it ABS. No, it's still plastic and it breaks. So we're very thrilled with all of these things that I bring to you. And we've got a great staff of people that follow all this and make it happen. And that is why that we're being really used by so many people. Then I come to the thing about receiving. See, I work in these companies. I'm in their factories and I'm going, why don't you do something about your receiver? Oh, our receiver. I'm not talking about sensitivity, selectivity. I am talking about your audio. Every one of these $15,000 to $400, they all have about 10% distortion. I'm not making this up, it's true. And they're awful, little 1 and 2 watt amplifiers. So that didn't ring for me. So what I did is I set out to bring in an incredible thing to this hobby. There are a lot of people that try to hoodwink you with the fact that, well, we got this and that. Yeah, right. Look how big that speaker is, that magnet. And that the amplifier is 25 watts at 0.1%. Every other speaker, every other amplifier, every other transceiver, they have about 10% great distortions. I don't want to hear that because it drives me nuts. We have a balanced line input, and the speaker cabinet, borrowed this from Paul Clips. The speaker cabinet is tuned to the resonance of that, the free air cone of that speaker. And it really, really plays big time. But what bugs me is that I see these other companies trying to force things on us, and I'm sorry, it doesn't work for me. So I did something about it. And thank the good Lord that Paul Clips came into my life, because Paul, he taught me how to do all this stuff. So now what are we going to do about the little box that drives it? This is a parametric EQ. It's a parametric EQ. And that is where the money hits the road, let me tell you. Because now we can change exactly what we need. If you look at the controls, there are 3 filters in this. And those 3 filters are set at 160 hertz. The top one's set at 6K. But what's the middle one doing? You know what it's doing. It's a parametric. And that parametric EQ allows us to do some really cool things. Here we are at 6K, 160. But look over here. We don't have one, we have 2 separate line amplifiers. They are not Y chords like all the other cheapos. No. These are separate low distortion amplifiers. So you can have a logger and an operator. But that's not where the big deal's coming today, I find. We're selling so many of these for people's television, computers, and so on. They put the left side of their headphone here, the right side here. So if they have a hearing imbalance, no problem. And it's just remarkable what we can do with equipment that we really need. This is another separate line out. You can plug that into your computer and make some great recordings. I'm going to play you a couple of them right now. I have them on a memory stick up here. These are coming straight off of 20 meters. And I get all levels hooked up here. And again, they were very, very nice, high quality recordings. I'm going to set everything flat the way you hear it. The only thing I'm going to do, this is the gain of this mid amplifier. Without any gain, it doesn't work at all, but we're just going to leave that there. We're going to set, I'm going to actually roll off a little high and some of the lows, and then we got this. Here's the way you hear this. You ready?
Echo India 8 Bravo, Lima Bravo, EIATLB.
There's the way you hear it, flat.
Sierra, Germany. Hope I have it right. Very good day to you from Ireland. Name is Berlin, India, Alpha Mike, over.
It is flat. The way you hear it.
Echo India 8 Bravo, Lima Bravo, EIATLB calling in by.
There's just nothing like this. There's some copies, but they don't work like this. And it's like, what in the world are these guys thinking when they bring this kind of stuff to the market? I know exactly what we need because I listen to all of you as I go out to so many workshops, and I do ham fests and things. Of course, in the last year I haven't done many, but I'm on the air, and I build this stuff for me first. Then I bring it to you. But I think you can tell from that, it's an incredible thing. I want to run by a couple of other things here. There's so much to talk about. But if you or any of you are watching Ham Nation, we did an incredible thing, started about 2018. It was a pine board project. It got a lot of play, so much so that QST did an article and it got the cover award. What it is, we were building each week. We would come on for about 15, 20 minutes and build pieces and parts. And what happened, we build the power supply first in the upper left, then the equalizer mic preamp. Of course it had equalization. It also has a switch that increases 2.5K. What do you think I did that for? And then the transmitter was 5 watts, 40 and 80 meters. And there it is all set down at the bottom. We had so much fun. And they're still building. The diagrams made it. W4IQN. He was a graphic artist for General Motors. And oh man, he did some incredible drawings. Look at those things. They're better than the old Heathkit drawings, if you remember those. That's really what made this thing fly. And all of this is on our website. You go to the Ham Radio side and in the search box, put Pine Board Project and you'll get, I don't know how many pages. There's still more at it because we got a lot of people. And it's a lot of people say, well, it ain't going to work, Heil. Where are you going to get the parts? Antique Electric Supply. You can even go there and order a Pine Board power supply, a Pine Board preamp EQ, or a Pine Board final. They have all of the parts there. And so that's all out there and going. And some really great things happened. There's a guy that built one in a cigar box. I thought that was really cool. And another guy, he all kinds of things. He built it in a guitar amp chassis that he had. Another one built it in one of his kids' lunch boxes and so on and so forth. We've had so much fun, and it's still going, even though I'm not doing the Ham Nation thing anymore. We're doing a lot of things. And sometimes the clubs will have me back. I'll do a whole hour just on this project. So there's just so much to talk about all the time. I do want to get on to one other situation before we walk out here. And that happens to be about phasing. Phasing is an incredible thing, and nobody talks about it much. And it really bothers me because it affects everything we do. How did Wes Shum get rid of the carrier when he brought single sideband to us? How did he get rid of the other sideband? How did the Yagi work? I mean, do you ever think about these things? It's all about phasing. Some guy calls up on top of your frequency, and there you got that big monstrous heterodyne. You hit the notch filter, he's gone. Well, how'd he do that? How's that work? It took his signal out of phase, he's gone. On and on and on. Well, I have this great demonstration, and I'm going to hook up another microphone pair. I'm going to unplug this for right now. It'll be something you, not only a couple of things, that the importance of 2.5K, but this could be something else for you to think about. Phasing, oh boy. I have two microphones, Paul Rogers' wonderful PR22, and what I use most of the time on my rigs, so articulate. But here's the deal. If I bring them together, it's going to double the output. We can see it on the meter. I should put a camera on that. When I do that, it's going to raise it, what? 3 dB. You ready? Because it could get kind of loud. We're going to go from 500 watts to 1,000 watts. Here we go. 1, 2, 3. Wait a minute. Remember a while ago I said listening is a mental process. Hearing is a physical. Everybody hears. But listening, you really dissect what you're hearing. I'm going to take away half of my power. Here we go. 1, 2, 3. The human being cannot detect 3 dB. But that's not why I'm here. I just kind of throw that in for something for you to think about. You know where I learned it, in that great big old book. I have this magic little plug. Pin 2 is hooked to 3, and 3 is hooked to 2. Well, big deal, Heil, it still works. It's just a Y cord, by the way. So I can have 2 microphones and 1 input. They both work just fine, don't they? Yes, they do. However, this one's in phase right here. This one is out of phase. Watch the screen and listen what happens when you take 2 signals that are out of phase. Nothing. They cancel. They cancel. Ready? Here, I'm going to do it again. 1, 2, 3. They cancel. Oh, they're still hooked up, but not together. Just think about how many things in amateur radio that these affect. What's the biggest one? Antennas. Really? You see, I wanted a couple of years ago to do this. So I did it so we could document it. Hang on. Okay. I built a phased array on 75 and 40 meters. They're 64, the antennas are 64 foot apart and 64 foot high. On 40 meters, it was only 33 foot apart and 33 high. Just about every backyard you can do that. Let's talk about this 75 meter. Then you take the down lead, it has to be 126 foot on 75 meters. You have to make that out of 213 or whatever, as long as it's 0.66 velocity. If it's not 0.66 velocity, the length changes. We want them exactly alike. But look at that red line. That couples it all together, and it's 43 foot, a big coil of it. And a remote switch allows me to switch either the left side or the right side. When I go to the left side, the driven element, that takes the rear down by delay. It delays because it has to go through that delay line. Watch and listen how incredible this is. I hope this works. I had some trouble a while ago with the audio. Hopefully we'll make her happen. There we go.
Of a 75-meter phased array antenna system, consisting of a pair of coaxial dipoles mounted atop a pair of 55-foot telephone poles. We put them in an inverted V fashion, and the poles are 64 foot apart. These are 500 foot from the operating position, fed with RG213. In order to make the antennas directly from east to west, we use a delay line, a 43 foot here on 75 meters that's switched in and out of the driven element, either east or west. The downlead length is 126 foot. We take all of that coax, the downlead length, the 43 foot phasing delay line, and mounted them in a container, one of the plastic container boxes that we actually buried. And just the top of it shows. It's all sealed, so it's waterproof. But that's the way we get to switch all the components from 500 foot using one of the Amatron RCS 8V remote switches. It really works well. Take a listen to how we can get at least 10 to 20 dB difference east to west.
Like a lot of people do. Mine's usually 3 inches or so. You know, that's just after you're done mowing. And I know that, you know, probably, you know, we get a dry day. I'm going to have to lay out there and mow. That's just all there is to it because, you know, if you leave it that high, when it starts growing in it all, it gets looking ragged pretty quick. So it's to that point now, and
the system really performs on weak signals. Take a listen as we switch to the direction they're coming from. Also note the preamplifier makes no difference on 75 meters on this signal. The preamp will of course make the meter read higher, but in many cases the preamplifier does not cause the weak signal to be more readable. Check it out.
yeah, well, I see they introduced big display on it, and I don't know if that is their form of portable, or what that is. Your wife, when that hooked up to your computer, did you use your handheld to go through it?
Pretty
There's some great
amazing, huh?
sounding AMs.
Wow, we've had so much fun with those phased arrays. I can't tell you how easy that was to build, and all of that, all that's in my handbook. I know the guys. Oh, there we go. Most of the stuff we're talking about here in this handbook, I didn't write it, I compiled it. These are just notes from all of the great engineers and people and important people I've met during my life. It's been a big help to me, and so I share it with you. That's available from our web store, or in your case, Martin Lynch, Waters and Stanton, they all have it, so you can check it out. But you'll want to check into some of these phased arrays. They really work. A friend of mine did one, and it's on 20 meters. He just took a 20-foot piece of 2x4 at the top of his tower and pulled down 20-meter inverted V's, and of course run the leads down. It works great. He's a big DXer and he doesn't have a lot of room for a tower and big beam and all that, so it works great. So those are very important things. The other one thing that I want to talk to you about is I had learned some time back that Art Collins had a thing talking about antennas. So I found that publication from Collins. What he stated, this is very important. His publication stated that most transmitting antennas of resonant, I hate things that's not resonant, resonant dimensions elevated at a quarter wave above ground, they're as close to 100% efficiency as possible. Go back and listen what I'm saying now. Elevated at a quarter wave above ground are as close to 100% efficiency as possible. So I thought, wow, let's try this. So I started playing with antennas on 40 meters. And of course, it would happen at any frequency. But your antenna does not just transmit one direct wave. There's another one. It's a reflected wave underneath yours. And the trick is, if you can get them together, it will be stronger to the receiving antenna. And the way you do that is by changing that length of B to C. And you do that by having that antenna a quarter wave, or leave some wavelengths above ground. I actually did an experiment one time. I should have did a video of it, but it was 30 years ago when I did it. I need to do it again and do some video, but I had a reference antenna, and every night I'd come on the air with a 40-meter antenna at different heights, but we always had that reference to make sure what was going on in the atmosphere that day. And when I'd go 20 foot, 40, 60, 150, when I got to 33 foot, whoa, well, there's the reason. When I got up to 66 foot, it was also stronger than anything else. So these are things that I don't ever hear about them. I'll tell you my personal thing though. There is nothing like a resonant dipole. Nothing. Resonant. And there's all kinds of configurations of it. But in a lot of cases, we don't have a lot of room. A friend of mine over in Kansas City said, I want to build an antenna in the attic, all bands. And so Jim built a 10-band fan dipole from 80 through 10. This is how he did it. Took a piece of fiberglass and put two strips of aluminum and then drilled all the holes so that all of the thumb bolts would go through that. And that's what he wanted to do. And here's how it looks. Jim has worked 100 countries with 100 watts. It is amazing. And for all the doom and gloomers, I just took one reading. Look at that 40 meter. That baby is very flat. But he cut them. They're all resonant. The only one that didn't turn out well was 6 meters, but he didn't care. He just wanted one particular frequency for a repeater frequency he worked. And it works great. Isn't it wonderful to be able to do things? Think about it. But there's just so much more. I'll leave you with this one. I get into a lot of trouble about this, and it's about putting coax connectors on. My mentor, back when I started in ham radio in 1956, he was an engineer, a chief engineer of CBS radio. And he did his coax connectors like this. He said, you don't solder them through the holes like the handbook tells you. because you cannot verify that all of the little copper strands are soldered. They might be touching, but they're not all soldered. There's no way they can be. Here's what you do. You go ahead and prepare it and solder the center conductor. And then take the shield, cut it all off around, and solder it to the connector. Now you have to, the best way is to tin that connector because it's going to get really hot. Tin that connector really good with a big iron all the way around it. Let that sit for about 10 minutes, make sure it's cool. And you have a perfect coax connector. Can do it with RG58, same thing. Tin that adapter first and then put it onto the center lead. When you're done, why, that's what it looks like. I did this for years and I never talked about it because people make fun of me until about 6-7 years ago. I visited Tim Duffy, K9EID. I bet you know who that is. $1 million plus contest station. I walk in and in the corner of the room are all these coaxes coming down. And every one of those coaxes in that $1 million contest stations were done like this. I said, you gave me heart here. This is great. I said, I never talk about it because people make fun of me. He said, no, you can't make fun of this because it's the only way you know that they're all going to be connected together. Tape them up, nobody will talk to you anymore. They don't know what's under there. You want to have an easy way to put things into your helm. Before this tile was down on the subfloor, I put a toilet flange, just like we were going to mount a toilet. And then put the tile down. It was really cool. It's a neat way to do things like that. But just all kinds of things. We could be here another hour or two, but time is rushing. So we better start winding it up and see if you have any questions that I might be able to answer. I bet you do.
Right, well, I'm just going to jump in here before we get going. I'm sure there'll be plenty of questions, and I'm quite nervous about speaking correctly into this microphone after all that talk. But that was absolutely fantastic. I very much enjoyed that, and I'm sure everyone else did. And there's so much to learn in there, and I'd like to say a very big thank you from all of our members. And well, unfortunately, it's a very visual thing on Zoom, as I'm sure you'll know, but a big round of applause for Bob. Thank you very much.
Thank you. Thank you.
We'll hand it over to the floor for questions.
Ooh.
Anybody got a question?
You're on mute, Robin.
Okay, I'll kick a question off then. At the beginning, great talk, Bob. Really enjoyed it. My name's Jim. I'm not quite as old as you, but I certainly remember the Grateful Dead. How did you manage to? How did you manage to survive the first 10 years of your life without losing your hearing?
Well, another side of that, usually, I thought you were going with this question. I'm 81 and a half, and I have never tasted beer. I've never smoked anything, and for gosh sakes, no drugs. And I'm running around with the biggest drug addicts in the world. But many of them are very good friends. And Pete Townsend always put it kind of cool because they'd go to passing out their drugs after a show. Leave the guy alone. He's got a soldering iron. He makes it sound good, and he can drive the truck. And so that's how I get out of most of that. But it's a true story. I can't even stand the smell of beer or any of that. So forget it, you know. And my hearing shortly after I started doing a few small concerts, a guy came to me and gave me ear valves, not ear plugs. They make them for shooters. It's a little cylindrical, aluminum cylindrical, that has an actual diaphragm in it. And anything up to 90 dB, a whisper, anything, no problem. When it gets up to 90 dB, the diaphragm just shuts it off and you don't even know it. It's a very cool thing. And I was very blessed that this guy gave me those ear valves, because I still do have my hearing. I have all, like anybody that's 80 years old, I've lost the top after probably about 10K or so. But boy, like Pete Townsend, poor Pete, he's down around 4K. And he was back in the day. So it was, you know, it's a blessing. I still have my hearing.
Well, I sure wish I'd known about those, because I attended far too many rock concerts and my hearing was wrecked.
I hope it wasn't our sound system.
No, but it's always funny at field day, because you know, I'm sitting in a tent and I've got the radio up and the earphones up, and then I hand it to somebody and they put it on and they immediately take the earphones off and turn the radio back down.
Golly. All right.
What about RF clipping on transmission, Bob?
RFI is a toughie. One of the biggest problems is people ground everything. And you can't do that. Because if you ground everything, you're creating huge ground loops. And so what you have to do is think about, when you ground things, what you're doing. And a lot of guys don't, because it's not written. And when I do anything about it, I'll show you something real quick here. I do have some slides on it, but I didn't happen to have some here. When you couple your gear together, now we're talking about the signal line, only the signal line. If you ground all that together like such, you've ended up with the big ground loop. And they have races. What are you talking about, Heil? To get from, let's say, from here to ground, well, we're going to go this way, and we're going to go this way, and we're going to go, well, yeah. Well, we also can go bang right to ground. You have two paths to ground. And then if the chassis is grounded through the 3-pin, this is the fuse box, by the way. You have a multitude of ground loops. And so what you have to do is break the shield on some of these. And you go, oh my God, it's not grounded. Yes, it is. It's grounded this way. And so you have to think about what you're doing when you're coupling all these chassis to ground. It's very important, but something that really isn't talked about much. And I don't talk about it a lot because I get into a lot of interesting arguments. And most of them are wrong. Well, you can't tell somebody you're not right. But I've learned from experience and all that. Very important, especially when we were on the road with all these bands. You can imagine what the AC requirement is for a band and an 8,000 watt PA. We always brought our own generator. It was a Caterpillar generator on a huge trailer, because I never trusted the building's wiring. We did it ourselves, thank you very much. And only our gear was plugged into that. It worked fine. But yeah, check your grounding. There's a couple of other things that ICOM, Kenwood, Yaesu. Did you know that none of those guys ground their shield of their microphone? I bet you didn't know that. And that always bugged me big time, that they don't ground the shield. Well, in the perfect world, that's okay in the broadcast world, but it's not very good when you're trying to do RF, because that a microphone shield has to be grounded. So what I always do, you go into a socket like a, let's see, you know what? I might have that for you. You go into that socket, that's, you know, the 8-pin Foster connector. We call it a Foster connector. Now, here it is. Go into that Foster connector and leave the ground now. Just leave that shield there, but it's not grounded. It's going into the amplifier. Take a piece of wire. It doesn't have to be red, by the way. Take a piece of small wire and solder it onto there. You do not unsolder anything. You solder the wire, connect it onto 7, pull it back, and wrap it around the cable clamp. And when you do that, you have connected that shield to chassis ground when you tighten the ring down. And that's helped a lot of people. And in many, many cases, that'll work. So I hope that would help you too.
Bob, Robin G4IWS. I'm quite pleased to see that you've got a Dora loudness meter on the shelf behind you under the red convertible, which I have one of those. I had it for checking the loudness of TV commercials.
Yeah.
But anyway, I spent 20 odd years designing equipment for the BBC, all sound equipment. Wow. So I've got a pretty good idea of a lot of what you were saying. But the biggest and most significant thing really is that what I'm used to just doesn't appear in amateur radio gear. And I'm prepared to accept that they've got a lot of experience in that area, so they do things differently. But there are lots of glaring mistakes, like you've just said, earthing stuff and whatnot. And we had a chap who was from Chicago. He did sound reinforcement, and he found that if you used a twisted pair to a balanced mic and a shield, you got a lot more pickup from all those medium wavers than you did if you didn't use the screen. And the reason is that the capacity between both sides of the balanced pair to the screen isn't the same all the way. And so he got far better results if he just didn't bother with the screen. And there's, and I'm sure there's a lot of that sort of thing hidden in the ins and outs of amateur radio. So your talk was great. I learned a lot. Thank you very much, sir.
Well, thank you. Well, I agree with you. I don't see a lot written. And of course, we're the only company that I know of in this industry that talks about balanced microphones, because all of our microphones are balanced. So the 781, the PR40, PR22, those are all balanced, and there's why. But the problem is the amplifiers, they don't use it. They ground the minus side and use an unbalanced microphone. My gracious, they got a great tool. Why don't they use it? They're the engineers. I'm just a crazy ham. And this really works. By wiring it proper, you can take a Kenwood, ICOM, I don't care what it is. You use the balanced input. The shield is on pin, 6? Yeah, it's pin 1 is the positive, the plus. Pin 7 is the minus. And then pin 6 is where your shield goes, because that's chassis ground. We solve a lot of RFI problems just by balancing that input. And you don't have to do anything. You don't have to rewire anything. You just have to have the right cable, which we build and supply. All of our cables are balanced. And so you're right. It's an interesting thing about balanced signals, because this industry, they do not understand balanced and unbalanced, obviously, because they still put their microphones out, which they don't build. That always bugged me. They just have them built by an OEM company. But that really works great to do that. But thanks a lot. And Mike Thoreau is a very good friend of mine, K06NM. We call him No Money Mike. Big AM station in California. Good guy.
The dark thing is they understand balance and not grounding feeders in aerials antenna, but they don't understand it in audio.
I hear you. I hear you.
Well, thank you very much.
Bob, a question, if I may. It's David, M0DHO. You talked about spatial awareness in headphones, and some of the techniques I see in some rigs is, rather than doing phase reversal, that you introduce a phase delay, and you can vary the amount of phase delay. And I know this is very much down to personal audio perception, but I've tended to find that gives me a better sound stage, a better spread across from left to right, with that kind of delay technique. Have you looked at that at all and maybe thought about that for your headphones?
Yeah, but I haven't done anything about it. I really haven't. But phasing is an incredible thing. And when I first started putting it in the headphones, a lot of people say, what are you doing that for? Until they use it. And then it's like, whoa, where's this been?
Yeah, I found it particularly useful on CW, where as you've got different pitches, it really spreads it across the soundstage and makes it easy to pick out from a combination of stations calling.
Exactly. Yeah.
Okay. So how they do it on the Ellicraft, David?
Yes, you've got an option there where you can have this kind of pseudo thing, and it's just done by a sound delay. But I think the delay itself is actually configurable through the menu. And the other thing you see very much with home cinema systems is that they try to simulate multi-speaker sounds through special DSP processing, but I'm not sure that would work well for amateur audio. I think it's trying to present a richer sound stage when what you're really looking for is clarity of audio.
Right.
Yeah, the thing on the Ellicraft works really well in CW. I agree with you. If you punch that in, suddenly the signals separate, and I assume it is a phasing thing, but it is quite effective.
It's just a phase delay between left and right. Yes.
Yeah, exactly.
A question for you, Bob. I see you've got a 706 on the back shelf.
I do.
You have. You've got a 706 on the back?
I do, yeah.
Yep. How did ICOM get it so bad that the microphones were so poor for the 706 and the 700?
How did they do what?
How did they get it so bad?
Oh, it's because none of them build their own microphone. They have it built by some OEM thing and offshore, and as long as it makes the meter move, they're happy. And I work for these guys. I mean, I'm talking about firsthand, eye to eye, and their plan is like, whoa. They got me to help them with the equalization. Why don't you do the rest? Oh, it's fine. Nobody ever complained. Well, everybody complains. What are you talking about? So I don't know why they didn't. We have all kinds of microphones that work, and even our hand microphone. I hate hand mics. I should hook one up and use it in these things. You see, anytime you take an element, you can take the best element in the world, and when you put it in a clamshell, that's what you got. You cannot argue with this. When you put an element in a clamshell, that's what it sounds like. I can pick out hand mics all over the place. And wait a minute, hang on. I think I do have one here. Show what I did. Did I have one here? Well, goodness. Yeah. Shucks. Oh, I'm sorry. I thought I had one here. I've got it over at the other shop. What I did is I opened up the whole top of it so that it, normally it sounds like this, and I open up the top of it and it gets rid of that tuning. It detunes that cavity, and it really works. I get guys will ask me all the time, what kind of mic? And I tell them it's a hand mic. They don't believe it. And so it really, really works. We even make one that's got a balanced connector. It's a balanced hand mic. And why I did it is a couple of the sound engineers, one of them for Carrie Underwood, we use talkback microphones from the console to the monitor. So like when we're setting up, we need to talk to the stage, and this microphone hangs there. Well, he was using a CB mic, and he said, man, it drives me nuts because they all sound like this, all pinched up and hollow. So I took one of our mics for him, and we've been building several now for the front of the house engineers. They love it because it sounds great, and it's a hand microphone balanced with an XLR connector. So I think I might put that on the market because I think there's a market for it. And it definitely makes the 706 come alive when we use one of our IC elements in it. Tell you that. Yeah.
Thank you for that, Bob, because there is somebody that does a lot of alterations to the microphone in the United States. And I think if you do that, you will have a product you'll sell.
Yeah, I hear you. Thank you.
Well, that is sort of like a talk box effect, isn't it? In sort of using it the inverse way around. And the talk boxes, you're changing the cavity which the elements are in.
Yeah, that's because that driver is narrowed down to a little 1 inch or so tube. So all of the sounds coming out of that tube, and they can talk. Frampton makes it talk. I mean, he really does make it talk. All the others, they use it. I always say it's kind of a guttural sound, and Frampton makes it say words. He's the best at it. But he said it took him a year to do that after he got that Christmas present from Penny that I had given him. It took him a year to learn. He had to learn the alphabet differently. Let me see if this, let me try something here. Let me see. Here you go.
Well, you invented it. You should know how it works. I don't play it though. Okay, thanks very much, Peter. We appreciate it.
Yeah, good stuff. Made his career. All right. Well, this has sure been enjoyable. If we don't have any other questions, I have 2 ways to end this little session. You can hit the stop button, or I'll walk over here in about 20 feet and I'll fire that up, and I'll play you a little tune.
Oh, brilliant. First class.
This just gets better and better.
I was going to say, Bob, you've obviously been in the sound business for many years. What do you think has been the biggest factor in your professional success? What would you attribute that to?
The biggest what?
What is the biggest factor, do you think, in your professional success? You've had a successful career. What would you say is the biggest factor in that success?
Ham radio is one, because I learned as a young child. I was only 15. I was building a single sideband rig for 6 meters. Ended up being one of the first 10 in the country. So the ARRL told me. And I love to build and I love to share it, but the other thing is listening, and I got that from tuning all those pipe organs. That had so much to do with it, and a lot of people don't hear; they just listen. Hearing is a it's just a physical process. Okay, I hear you, but listening is a mental process where you get in and listen to all the little nuances, and that right there at the age of 15 also when I started, and I'm still doing it, and it really has helped me, especially in my sound reinforcement days, to be able to listen and also try to build something that they needed, and that's something else.
Yeah. All right. Thank you, Bob. Well done.
Well, thank you. Okay, well, I'll go fire up the big theater organ and we'll see what happens. Let's do it again. I'll come back and let's pick out a subject. I got a whole hour just to talk about antennas. Or
We'd
another
love
one.
to.
Yeah, absolutely.
We'd love to.
All you got to do is send me a note. Tell me what date I'll be here.
Yeah, we'll do that.
Because it works great for me. It's in the afternoon. I'm just sitting around here doing other things anyway. Like I said, this was number 276 I've done since February 2020. So do a lot of these, but not in the afternoon. Okay. Thank you, everybody.
Thank you. Thank you very much again on behalf of all of us.
Thank you.
Thank you, Bob.
Go over here and fire it up. Okay.